Exactly. Okay, now we're going to take, not sodium, but let's take zinc. Okay, so you can see I changed the type of metal here on the left-hand side. Blue light, does it emit electrons? No. Okay, I make the intensity more. 100%, still no electrons transmitted. Okay, I'm going to take the intensity down a bit. But if I move it, the frequency up, UV light, higher frequency, there it starts to emit electrons. The intensity is not a lot, but what did I change? I changed the type of light. The type of light that is shown onto this piece of metal. Now electrons will be emitted. Okay, so 3 things that you should know now. Number 1 is when we change the frequency of the light, we change whether or not electrons will be emitted. Okay, then each metal will have its own type of frequency that emits electrons. Okay, so zinc now, he needed high UV energy, whereas sodium was a light blue light and it emitted electrons. Okay, so each metal is different. And then I want you to see with the intensity. If I increase the intensity, then you'll see, okay, I'm just going to increase. Okay, go back. So, sorry, there you can see the intensity is very low, 17%. Now it emits 1, 2 electrons at a time. Okay, but if I make the intensity higher, you can see it emits more electrons. Okay, you can see that? Okay, so can you see the current now is a lot bigger, whereas if I make the intensity less, the current goes down. Because what is current? Current is how many electrons pass a point per second. So if there's less electrons jumping, the current will be smaller. Okay. So another thing that you must see is if we increase the intensity, more electrons will be emitted, the current will be bigger. Okay. Yes? Let's just play. Let's take another one. Let's take platinum. Okay, so platinum, you can see now, not even this UV light will give off electrons. So now we must take the energy higher, and only now it gives off electrons. Yes? We can try gold. Do I have gold here?
What material is inside
I don't have gold. Say again?
What material is solar panels that the sun is facing?
Oh, I don't know. Wat heb ik nou vir julle gesê? I don't have gold. I only have these options. So that is copper right there. Okay, so this is what this whole chapter is about, and we're going to change the 3 things. We're going to change intensity, we're going to change the energy of the light, the UV light or infrared or blue light or whatever, and we're going to change the material, copper, platinum, zinc, whatever. Okay, then I'm going to start with the notes, but I know you don't have them in front of you, but you have an electroscope in front of you. Yes? So you can use them 2, 2, 2, and I want you to please take out a ruler. Yes.
I can do something.
There you go.
Pak het af even.
After. Okay, so what I want you to do is take your ruler, make it nice and warm between your jersey and your blood. Okay, then I want you to bring it closer to the electroscope. Don't let it touch, just closer. Okay, you'll see it deviates, the little leaf, it deviates. Okay, now touch it. Okay, and take it away. And it should stand more or less. It should stay more or less where it was. Not? Wat het julle gedoen? Bly hy nie? Okay, so don't worry if it doesn't stay. Okay, so this is your nose that you will get soon. But if you touch it and it stays there more or less, it means that you have charged the electroscope negative. So it means there's excess electrons on the electroscope, and the leaves will go up because negative and negative repel one another. Okay, now the photoelectric effect says that if you now shine a light on this, or the correct light on it, then all of a sudden the leaves will go down. But like, why does it go down? It means the electrons that was in excess on this electroscope left. But the question in this chapter is, why does it leave? Okay, it leaves because something attracts it. It leaves because the electrons jumps to somewhere else. And that's what we're going to investigate in this chapter. Why does it jump? Where does it jump to? How does it jump? And that. Okay, right, now you can touch it again if you want to, and it should go down more or less. Because you take that excess electrons on you. Okay, so I'm going to read and then explain. It says here that when UV light, ultraviolet light, shines on a piece of zinc metal on top of a negatively charged electroscope. Okay, so there is your electroscope that's negatively charged. Now you shine this UV light on it, on that piece of metal. Then it says the electroscope loses its negative charge. That means the electrons are therefore forced to leave the metal. They jump. They go somewhere else. Okay? And these leaves go towards each other again. Okay? Now, why does that happen? When you shine a light on it, these electrons get that energy from the light. We're going to look at that again a bit further on. And then the electrons jump to something that attracts them, to something that is positive. Okay? Or it can be that it becomes too negatively charged and they jump away from each other. One of the two. Now, it says here, the higher the intensity of the UV light, the quicker the discharge. It means the more light you shine on it, we saw that in here, we saw that if I increase the intensity to 100%, then more of them will be released. But if we make the intensity less, then less will be released. Okay, so that says discharged quicker. Then white light. Now, does white light have lower or higher intensity than UV light? White light. It has lower. Okay, intensity or frequency cannot release electrons from zinc metal. So that's what we saw. If we choose a light that does not have the correct frequency, then no electrons will be transmitted. Okay, and that is called the photoelectric effect. The photoelectric effect says, the process where electrons are ejected, released, given off, from a surface metal when light of a suitable frequency or the correct frequency is incident, means shines on the surface. So what is the photoelectric effect? Is where electrons jump from a piece of metal when the correct light shines on it. Okay, now the frequency of the radiation, how it moves, that determines whether electrons will be released or whether will not be released. Okay, so this is what I said here. If I choose a different color light, then electrons will be released. But if the type of light changes, then no electrons will be released. So the frequency, the type of light will determine that. If the frequency is decreased, okay, so make it smaller, then a frequency will be reached where no electrons are emitted. Okay, I'm going to show this again. I'm just going to choose an easy one. I'm going to choose sodium. Okay, so we said with sodium that at some point, sorry, I'm just going to up there. At some point there, now electrons are being emitted. Okay, so that point where not emitted emits, that's a very fine line from doing it and not doing it. That is called the threshold frequency. The threshold frequency, and the symbol for that is F with a small 0 at the bottom, meaning the starting frequency, the 0 point frequency. Now, where have you heard about the word threshold? Where? Medicine. Where in medicine? The what? I can't hear.
It's a mom.
The MRI scan? Or the CAT scans? No. Maybe I'm wrong, but I can't think of it. What do you call this thing here? What do you call that? And another one for that? Good. Where are we with our questions? Did you answer? What did you answer? Tell please look up the word threshold. Threshold. Okay, so while Sam was looking that up, so that frequency where electrons are started to being emitted, the starting point, that is called the threshold frequency. Okay, and it depends on the type of metal. We saw here that for sodium, the threshold frequency was blue light, but for zinc, the threshold frequency was somewhere in the UV light. Okay, so for each type of metal, it will be different. Okay, so the definition here of the threshold frequency is I'm going to be there now, is the minimum frequency of light needed to emit electrons from the metal's surface. The minimum frequency needed. Yes, Siamo, please explain to the class. You can read.
The threshold, entrance, door, doorstep, or a doorway. It is the start, beginning, brink, dawn, your inception, opening, outset, and bridge.
You guys hear?
Yeah, we can hear.
Yeah.
Okay, entrance. Okay, to start with.
Okay, so a threshold is the same as synonyms. Yes.
Entrance, door, doorstep, doorway. And then a start, beginning, brink, dawn, inception, opening, outset, and bridge. And then minimum, lower limit.
What?
Yes.
Okay, so wait before you back up. So threshold is that brink, that starting point, that this is a line, now you're over the line. Okay, so threshold is like a doorstep, in or out. Okay, so threshold frequency is that point, that frequency where it starts to emit. Yes.
Is it almost the same as the common line?
So what?
Common line. The common line.
Common line. Between what?
Exclusive.
Yes.